Recall, as we discussed in a previous lecture, Euler angles are one way of representing general 3D rotations. General 3D rotations. Okay, so here's an example of Euler angles. Okay, say we have some frame 0. So this is frame 0 with some axes ex0, ey0, ez0, and then we convert that set of axes by rotating by some angle alpha about ex0, say. Okay, and you get some new system. Let me not draw it, but you have some new system. Let's call that 1, and then which has ex1, ey1, ez1, and then you rotate that system by, let's say, beta about ey naught, and then you get some frame 2 and then you rotate that frame to get frame 3, rotate by angle gamma, right? So this is angle alpha, this is angle beta, angle gamma about ez, sorry, I should have said ey1, not ey0. In other words, the y-axis of this frame. And then here we want to rotate by the z-axis of this frame. Okay, so we are going from frame 1 to frame 2 by rotating about this axis. We're going from frame 1 to frame 2 by the y-axis of this converted frame, so transformed frame. And then we are going from 2 to 3 by rotating about angle gamma about ez2. Okay, so what do we mean here? So we are rotating the frames 1 by this quantity. Similarly, we are rotating frame 2 by this quantity, and similarly here we are rotating frame 0 by angle alpha about ex0, and so on. Okay, so we are converting this to this, this to this, this to this by a sequence of 3 rotations, and they are 3 elementary rotations, right? So this is a sequence of 3 elementary rotations. Whose rotation matrices we already know. We've already written them down in an earlier lecture, so we know this. We know 1 to 2, and we know 2 to 3. Okay. The full rotation matrix, of course, is the composition of these things. Full rotation R 0 to 3 is going to be actually R, so it goes right to left, R 0 to 1, and then you operate on that to get 2. So the output of this gets operated on this 1 to 2, and the output of these two things get operated on 2 to 3. Okay, so this is the full rotation matrix to go from 0 to 3. The full rotation matrix R 0 to 3 is a function of the three angles alpha, beta, and gamma. And this rotation, this full rotation, can represent any 3D rotation by appropriately picking alpha, beta, gamma. Okay. And then these three angles are called Euler angles. So alpha, beta, gamma are called Euler angles. In fact, they're just one choice for Euler angles. Alpha, beta, gamma, as defined above, could be called, or is called, X, Y, Z Euler angles. And the XYZ refers to what sequence of rotations we are making to go from frame 0 to frame 3, right? So what we're saying is that by doing these three elementary rotations, frame 3 can have any general rotational configuration compared to frame 0. But the sequence of rotations that we used to arrive at frame 3 is important. And the sequence is X, Y, and then Z. So that's what we happen to use. We can use any number of different sequences, can use other sequences as well. So you can use X, Y, Z, which is what we used, Y, Z, X, Z, X, Y. That's one possibility. And then we can go X, Y, X, X, Z, X, Y, X, Y, Y, Z, Y, Z, X, Z, Z, Y, Z. Okay. These are all possibilities. What are the other possibilities? We can also do X, Z, Y, Z, Y, X, and Y, X, Z. Okay, how many did we get so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 different possibilities. Euler angle possibilities. Right, so where something like ZYX will mean first a rotation. Let's actually do ZXZ or something like that. ZXZ Euler angles means first rotation let's say by alpha about EZ naught, second rotation by say beta about EX1, Okay, so it's going to be the x axis of the new coordinate frame 1, and then the third rotation by angle gamma about EZ2. So this is why you go. This is how you go from um, so this takes you from 0 to 1. 0 to 1 is accomplished with this. 1 to 2 is accomplished with this, and then 2 to 3 is accomplished with this. Okay. So that would be called ZXZ Euler angles. And because rotations are not commutative, each of these Euler angle systems is a different Euler angle system. You can use any one of these things, but the order of rotations matters. Each is a distinct representation. Each order is a distinct representation. Choose whichever is convenient. The order of rotations matters because rotations are not commutative, right? In other words, A times rotation 1 times rotation 2 is not the same as rotation 2 times rotation 1, which means that if you pick some Euler angles, you should always retain that order of rotations for every calculation that you do. And choosing one set of Euler angles, alpha, beta, gamma, in this Euler angle set will give you a very different final rotation compared to alpha, beta, gamma, say, for this Euler angle set. So that's very important to remember. And as an aside, these kinds of XYZ Euler angles might be referred to in sort of popular scientific literature as Rolle, Piccia, could be a set of Euler angles depending on the sequence of rotations that you pick. And again, you have to pick the order of rotations to be able to say meaningful things about what the final configuration is given the angles. Okay, the order is super important. So those are basically Euler angles, and we are always rotating about one of the new axes. Okay, you can also rotate always about an axis in the original frame as opposed to one of the new frames. So you can always rotate about, so first rotate about EX naught, then rotate about EY naught, then rotate about EZ naught. That is also a valid representation of three-dimensional rotation. We are not going to particularly use those things, so I'll skip over that. The other thing I want to talk about briefly is why only these orders. Why not order like XXZ? If you do a sequence X at next rotation and then a next rotation and then a Z rotation, you have two X rotations. Those combined to have can be combined into a single X rotation. So an XXZ is not a valid Euler angle. XXZ or YYZ, etc., are not valid Euler angle sets because you can convert the yy to a single y. So yyz is just the same as a yz. First a rotation about y, then a rotation about z implies it's only a 2 DOF rotation, not a 3 DOF rotation. Okay, so it cannot really span the space of all rotations. It can something like a YZ a rotation about y and a rotation about z can only span a two-dimensional subset of all possible rotations. So that's why these would be illegal, not legal Euler angle sets. Okay, and that's it for Euler angles.